Hi, this is Charlie Turnbull. We need to talk about acidity. Acidity. It's one of those things that lots of people have an awareness of, and maybe you've heard the words pH and got an idea of what's an acidic thing or what is an unacidic thing. In cheese making, it is front and center in terms of its effect on the cheese making process, and in not just one way, in a number of ways. So we're going to spend a little bit of time talking about what acidity is, and then we'll jump on how it's measured and how it affects cheese making during some of the cheeses we're looking at. Right. So acidity is a liquid. It has to be a liquid, and it's the degree to which there are free H plus ions. Okay, H is a hydrogen nucleus. Okay, it's a little hydrogen nucleus zipping around in the liquid. Now, it can dissolve pretty much anything if it's strong enough. Now, the H plus ions are like little, they are little weevils, and they get into molecules and start knocking bonds all over the place. They are positively charged, and they're looking for things negatively charged, so they can to create a little bit of a firm bond. And when you bond something, everybody gets a lot happier. All the molecules kind of settle down. So the purpose of them in their minds, those little H plus ions, is to go and find something to bond with. And the more of these H plus ions there are, the more corrosive the acid becomes, because there are just thousands of these little things going and trying to break something up. Now, there is a balancing thing called alkali or base. So if you think of hydrogen ions, positive hydrogen ions knocking around in a liquid, and excessive hydrogen ions being acidic, the other part of it is OH ions. OH, oxygen and hydrogen bonded, and they are negatively charged. Okay, negatively charged. And there are a whole bunch of them knocking around. That would make it a base. And if your OH and your H plus are in balance, it is neutral. Neutral. This is just chemistry. We are not going to explain why H plus is important and why OH minus, why those particular things make bases and make acidics. Oh God, I'm losing my tongue. Make acids. All we need to know is that they are important and they exist. Okay, so we're going to deal with the acidic end of the spectrum. Now, so let's get, we're going to put some, some slides against this. What is acidity? And we will work our way through this just to make sure that we're really clear what is going on. So acids and bases corrode material due to these free ions. The pH scale measures how strong acids and bases are. Okay. It's not a scale in the sense that, 1 meter, 2 meters, 3 meters makes sense to you and me. We can visualize that. It's a scale that pivots on the number 7. Pivots on the number 7. Now, on that scale, anything that's higher than 7 up to 14 is a base or alkali, and everything that's lower than 7 down to 0 is an acid, and that's acidic. Acids have an excess of H plus ions. Bases have an excess of OH minus ions. 7 neutral. There may be H plus ions and OH minus ions knocking around, but they don't do anything because they cancel each other out. Now, it's a logarithmic scale, which means 1 point away from 7 is 1/10 of 2 points. It's 100th of 3 points. It's 1,000th of 4 points. So it gets increasingly acidic, very, very acidic. So getting close to 7, there's not much change. But as you get further and further and further away, it becomes more and more and more. And it sort of goes exponential towards the ends, if that makes sense. So we have to be quite aware of that. Now, let's get into where acidity works in milk and water and cheese. Now, one of the key elements, this is water, distilled water with nothing in it except for water, which is H2O, literally a hydrogen. So 2 hydrogens and oxygen, that's all there is in there. That is 7 neutral. It is neither acid nor basic. So that is our pivot point. That is our pivot point. Milk, which is not all water, there's quite a lot of other stuff, 13%, as we know from other sessions, is slightly basic. So let's look at some of the acid, some of the basic and acid characteristics we'll look up. So pure water 7 pH, milk 6.7 there. Some people say the average of milk is 6.6. Milk being an organic material produced by cows all over the world, it's never going to quite always be the same. So 6.6 to 6.7. Now, if we look at these other cheeses, let's go down right to the bottom at 4.6 pH. Now, this is a magic number and you need to remember it, okay? 4.6, 4.6. 4.6 pH. Why is that important? It's called the isoelectric point for caseins, and it's where all the caseins will magically drop out of milk. Okay, they just drop around the milk. Getting close, they'll begin to curdle up and all that kind of stuff, but at 4.6, they'll go, oh, I no one want to swim around in my milk. I want to be in the bottom in a lump. Okay, and that means down there at 4.6, we want to take cheese making to begin with. We need to get down to that isoelectric point to start coagulation. So when we go from the 6.6, 6.7 and milk using lactic acid bacteria, we're driving the acidity down to 4.6, about 2 points lower, 2 points lower. Then we get coagulation. Now, most cheeses come back up to different degrees. Now, 4.6 for things like fresh cheeses, really young cheese with still a lot of acidity knocking around, cottage cheese, feta cheese, soft cheeses. We then move up to Cheshire, crumbly cheese, 4.7 to 4.9. Moving up again to cheddar and Gouda, which is 4.9 up to 5.3, hard cheeses. And then we get up into our hard cooked cheeses, 5.1 to 5.4. So the more that we travel on the milk train from milk all the way to the big make of hard cooked meat, the more the acidity is allowed to rise back up. Sometimes it doesn't go all the way down. The effect of it is that we're seeing a spectrum of pH across the makes. Now, there are some funnies, and they tend to be ones where we've got post makes involved. This is where we need to raise the pH for some reason or other. And we need to do it for camemberts because we want the molds to grow, and they aren't going to grow at those low pHs. We need a higher pH, less pH. So we allowing the pH to rise, and it almost gets back to milky levels, so 6.2, 6.5. Likewise, blue cheese, we need those molds to thrive. They're not going to do it at the low pHs. So again, 6.2 to 6.5, very near the pH of milk. Very near. And then we've got ricotta up there, and let's just ignore ricotta at this time because why? Ricotta is not a casein-based cheese. It's not a casein-based cheese. So let's just make sure we're on this. So isoelectric point 4.6, and then from softs, we go up a bit, crumblies up a bit more to the top 4s, hards, the low 5s, alpine cheeses and parmesans, pardon me, the 5s there as well. So it's very much a case-by-case basis. We use different techniques at different times. Gouda, for instance, because of washed curd, we're taking out some of the sugars, so there's less acidity in a Gouda because of the washed curd technique, so it behaves more like an alpine. I hope that's clear. It's clear. That's an understanding of where pH sits in cheese making. But it doesn't just apply to the cheese make itself. As we're going to find out, it's critical for curd structure. Acidity can knock out calcium bonds, which is about the elasticity and the crumbliness of the texture of the curd. So those low pH, high acidity cheeses have reduced bonds, and the high pH, low acidity cheeses, the alpines, have more bonds. And that is an essential part of the understanding of why cheese goes from the Cheshire-like, where is my Cheshire? You haven't got a Cheshire. We've got a Lancashire. We've got this crumbly. Let's get some more time in front of the camera. Some crumbly, yeah. Up through our hard cheeses, which cracks, to our alpine cheese, which is elastic. Okay, more elastic there. And that's because of that acidity. So we need to know about this acidity. Okay, right. We're going to move on to what else acidity does. Such an important subject. Okay, coagulation. Coagulation. So what does it do with coagulation? It just makes it happen better. When you get your rennet in there, if it's a low pH, the rennet is going to perform better. It's an essential element. But of course, as we know, it can be a coagulant in its own right. That 4.6 will coagulate anything. You won't necessarily get the cheese you want as an outcome, but will the curd drop out of the milk? Yes, it will. And it speeds up enzymatic rennet coagulation. So very important coagulation, whether you're renneted or not, you need that low acidity, high acidity, low pH. It in itself kills or reduces bacteria. Okay, now that is a critical part of the history of cheese. Cheese, because it's a milk, because it's like, golden food for pathogens, we need to drive down acidity to make the cheese safe. In the old days, before pasteurization, this is a critical step. That down to 4.6 was an essential part of making the milk safe to use and making the cheese safe to eat. Now, it's not the gold silver bullet that pasteurization is, but it's critical, and it holds the cheese back from developing more pathogens until you can bring other steps in place, such as drying, reducing the moisture. It's also used in pasta filata curd formation. So when we're making spun paste, pasta filata, we use high acidity and we use hot water, and it bonds the curd together into those filaments. And finally, the action of the cheese, of the acidity onto the cheese, leads to affecting how the cheese will melt. The lower the acidity, the higher the pH, the more melt, the higher. So things like halloumi and Cheshire, they do not melt. They're high acidity cheeses. But low acidity cheeses like Alpines and that kind of thing melt very nicely. Thank you very much. Now we're going to have a quick look now about how you measure acidity, because that's kind of important. Now, this is a very quick slide. Essentially, the exam asks you to know two measuring techniques: titratable acidity and pH. Titratable acidity is old school. Nobody uses it anymore. It's in the old books. People who talk about titratable acidity are trying to blind you with their grey hair. So we don't need to know much about it. It's very old. It dates from about the 1850s, and it has different scales. There's a German scale and a French scale and a British scale, and nothing really comes together. And it certainly doesn't hit chemistry, modern chemistry at all. It's measured by taking your acidity, your acid compound, whatever it is, and adding an indicator which will change color when it becomes neutral. And then you then add little bits of alkali to it and measure the alkali you put in by titration tube. Point little pipette. And the more you add until eventually it tells you where you're starting 1 point. So you can track it back by finding out how much alkali you've had to make it neutral. You'll have to do titration if you ever did chemistry O-level or A-level or that kind of thing. So you kind of probably know what's going on. But we don't need to know much about it. We just have an awareness of it, and that it's usually measured in percent lactic acid percentage. More important is pH. pH is the gold standard in acidity measurement. It's fully international. Everyone uses it the same. And it's small p, big H. It's a logarithmic scale, as discussed, which means the further away you get from 7, the more extremely acid or the more extremely base you get. And you can use a pH meter, which is great. They're not cheap, but they are very effective. And now every cheesemaker is going to have a pH meter, because we need to track that acidity through the cheese make process. So very important. You can use little paper slips. I don't know if you remember them from your school days. Maybe you didn't do it. Maybe you did. It's like a little kind of thing you pee on for if you're pregnant or something. It's like really, that works. It works, but for accurate measurement, not brilliant. Better getting a pH meter out. Okay, I hope that's a good understanding of pH. It's corrosive at its extreme end. Put your hand in, only bones are coming out. Maybe not even that. But at the milk end, you're absolutely fine. 6.6, 6.7. Drink it. You're a very happy person. I will see you later for the next step in learning our cheese science.